I want to start I want to start lesson 2.8 on absolute value functions, but by reminding you about a couple of functions that you talked about in Algebra 1. One of those functions was a linear function, and the other that you talked about a bunch was the quadratic function. Now, I'm taking these notes on graph paper just because I think it'll be easier for you to understand if you can see things to scale, but you don't need graph paper by any means at home to use. So let's start off with linear. Linear, we talk about something called the base function or the parent function. It looks like this, y equals x. And on the y equals x parent function, it's like you have a slope of 1 and a y-intercept of 0. So the parent function for linear begins at 0 and has a slope of 1. So it looks something like this. The table of values for this one looks like this. If you put 0 in for x, you get 0 for y. If you put 1 for x, you get 1 for y. In fact, on the parent function on this one, they're always going to be the same because y is equal to x, so those look the same. Now, in Algebra 1, you started changing things around a bit. I'm going to get a colored pen here. So you would do some different things to this x that would maybe change your graph a little bit. So let's start by just looking at what would happen if instead of having y equals x, I graphed y equals 2x. So what happens when I put a number right here in front of the x? Well, what that does is actually changes the slope. You begin at 0, but instead of going up 1 over 1, you go up 2 over 1, up 2 over 1. If you change that number to something smaller than 1, like a half, instead of going up 1 over 1, you go up 1 over 2. So what that does is it makes this line a little less steep. So the pink line was steeper, and the green line was less steep, or flatter. So we know that putting a number in front of the x is going to change the slope of the line. It's going to change the steepness. Also, if you would take that line and put a negative in front of the x, that would actually make the slope go something like this. So it takes this line that you had and reflects it over the x-axis, because the opposite of whatever x is what y is going to be. You also did some things to the graph, and we're going to investigate this on the graphing calculator in just a moment. But you also did some things to the graph, such as adding in numbers. So if I were to take this graph, and instead of having y equals x, which is the solid pencil line, let's say I had y equals x plus 2. So by adding a 2 at the end, it would just move the whole graph up. It would have the same slope, but the graph would be moved up 2 units. So you did that in Algebra 1. You also talked about quadratics. And when you graph a quadratic is one that has x squared. Let's just think about the parent function before we shift it. If I put 0 in for x, I get 0 for y. If I put 1 in for x, 1 squared is 1, so I get 1 for y. If I put negative 1 in for x, when I square negative 1, I get 1. So it looks like this. If I put 2 in, I get 4. If I put negative 2 in, I get negative 4. So this was a quadratic graph. And we're going to talk more extensively about a quadratic in the next couple of units. But let's think about this. If you put a number in front of x, so like y equals 2x squared. So if I put a number here, what that's going to do is after I square the x, it's going to double in order to get the y value. So if I graph 2x squared, this 1 is going to double to 2, the 0 is going to double to 0, the 4 is going to double to 8, So the y value is going to increase by 2. So instead of 1, 1, it would be 1, 2. And instead of 2, 4, it's going to be up here at 8. So putting a 2 in front of the x squared, it doesn't really make it steeper because you don't have a steep parabola, but it takes this graph and it pulls it vertically. So it stretches it vertically. If this number 2 was a decimal, like a 1/2 instead, it would make this parabola wider. If it was negative, it would take this parabola and move it upside down. If I added a number, like I put a 1 here, it would move this parabola up. So let's just do a little investigating on our calculator. If you have a graphing calculator at home, you can follow along. If you don't, you can look in Chrome. There's an extension for the TI-84 graphing calculator. You need to put that on your computer because we're going to use it a lot this year, and you're going to want to have that. So I'm going to try to teach you how here. So you're either on your own graphing calculator, or you're on your Chromebook TI-84 that you've got the extension for. So if you need to pause and go get that on there, do that. So I'm going to start off by just practicing graphing a line. So I want to graph this line right here. If you'll notice, there's a button at the top that says y equals. So if we push that, then it brings up a place where we can type an equation. And I'm going to go ahead and clear out the equation that I have there. And I just want to type in x, and x is the button by the green key. And then I'm going to hit graph. So there's the graph of y equals x. It's just like the line we made first with our pencil. We can look at the table for this graph. If you'll look right above the word graph, it says table in blue. So you could push second graph, and then it's going to show you the table that goes along with it. So you can see here the x and the y values all along this table are the same because our graph is y equals x. Let's go back to the graph. So push y equals again. This time, let's go down and put a second one in. So let's try 5x. What should happen on this one is it should make this line steep. In fact, it's going to take every x value and multiply it by 5 to get the y value. So let's graph it and see what happens. There's y equals x, and there's y equals 5x. You see how it got steeper. Let's go look at the table. So I'm going to hit second. Oops, I better go back to graph. I'm going to hit second table, and there it is. Let's go down and look at one like the number 1. 1 is for the y equals x, but then to get the y on the second one, you multiply by 5. So I have the point 1, 5. And you should have done this sum in Algebra 1. If I go back to y equals and take out that second one, if I type in x plus 3, what should happen is that graph should move up 3 units. So there's y equals x, and y equals x plus 3 is going to be the one that's shifted up 3 units. Let's go try x squared. So I'm going to go to the other side of the paper here. So to type in x squared, I'm going to push y equals so that I can type in an equation. I'm going to clear out the things that I have on there right now. And I'm going to type in x squared. So x, and then the square button. And this should draw a parabola. So let's investigate here. What do you think would happen if instead of x squared, I put 10x squared? Think to yourself, what's that going to do to the parabola? Every y value is going to be increased by 10. So when I graph it, you can see how it's actually going to stretch way out. So instead of over 1, up 1, I'm going over 1, up 10. So this parabola is stretched vertically. It's much narrower than it was before. Let's go back. I'm going to change it. And this time I'm going to type in negative x squared. Typed in the wrong thing here. X squared. Better do it again. Negative x squared. So this thing should reflect over the x-axis. All the y values now become negative. So it's a reflection of the quadratic that I had before. Here's x squared, and negative x squared looks like this. You might want to pause this video now or just not start the next one for a minute and play around with your graphing calculator, and then we'll start absolute value functions.